Hi everyone, let's look at puzzle number 2 of the quadratic family. So you can notice you're given the equation and we have the parent function, the parabola, but then we have it made negative and shifted up 6. So already I know that my vertex will be plotted at 0, 6, and then it will be an upside down parabola or reflected over the x-axis. So going into our graph, we can plot our vertex at 0, 6. And then if you want to use the rhythm of a parabola, over 1, down 1, over 2, down 4, over 1, down 1, over 2, down 4. This is also reflected in the table of values. So if we go over here and we know our vertex is at 0, 6, then we could either substitute in these x values or use the rhythm of the parabola. So let's just substitute in one of the x values. So let's go up here and substitute in 1. 1 squared is 1. Made negative is negative 1. Negative 1 plus 6 is positive 5. Otherwise, I could go over 1, down 1, over 2, down 4, over 3, down 9. The next thing we're going to do is look at the key features. So right away, I know that the vertex is at 0, 6, and therefore I know that my axis of symmetry, cut down the middle, is at x equals 0. Some of us, I'm noticing on whiteboard work, have just written down 0. You should make sure you write down the complete sentence. X is equal to 0. Our x-intercepts happen here and here, and they're a little tricky to find because I don't see them on my table. The x-intercepts happen when y equals 0. So what I can do is substitute 0 into this equation and set it equal to our equation and solve for x. What x values do the x-intercepts happen at? 0 equals negative x squared plus 6. Working PEMDAS backwards, subtract 6 on both sides, divide by negative 1, and then undo the square by taking the square root. A friendly reminder, you have two x-intercepts, so that's when you take the square root, it's both positive and negative. Domain and range. Since our vertex happens at 6, our range will be y is less than or equal to 6. Slope, not relevant. Our a value is a number in front of x squared, so that equals negative 1. It's concave down. Our y-intercept happens at when x is 0, and in that case, I could either substitute 0 in here, and I would get 0 plus 6, which is 6, or I can just see my vertex is at 0, 6. And then domain is all real numbers. Function notation, this is at saying, okay, what is the y value, and I'm going to give you the x value. The x value is negative 1. Negative 1 squared is positive 1. Positive 1 made negative is negative 1. Negative 1 plus 6 is 5. Oh yeah, it's also in the table right here. Reading function notation, I labeled my rate of change. If I always read it left to right, so if I'm working left to right and I follow left to right, this is increasing, so that's when it's above 0. This is when the rate of change is decreasing, so that's when it's less than 0, and here's where it's stopped. It's neither moving up nor down. The rate of change is 0 there. It was reflected over the x-axis because it's upside down. It did not have a vertical stretch because the rhythm of the parabola was still over 1, down 1 because this was 1. I suppose you could say it had a vertical stretch of negative 1, but you already said it was reflected. It was shifted up by 6 units, and then it wasn't shifted left to right. Last but not least, our problem solving and algebraic fluency. I'm asked, when does our pattern hit a y value of 4? So I plotted in orange the y value of 4, y equals 4. And I could also do that on Desmos. I can say, okay, if we have f of x equals negative x squared plus 6, I want to know when does that hit a y value of 4. So I can click on my intersections, and those are our graphical solutions. And we can tell that those are not going to be easy numbers. So if we go back here, what exactly are those? Whoops, studies. Negative x squared plus 6, our pattern set equal to 4. PEMDAS backwards, subtract 6 on both sides, and we have negative x squared equals negative 2. Therefore, x equals 2. Therefore, x must be the positive and negative root of 2. I can double check that on Desmos and make sure it matches. What is the square root of 2? 1.41, and that matches the solution, the decimal that Desmos got us. So there are some hints and solutions for puzzle number 2.